Hello everyone. In the previous video, we discussed three approaches to the problem minimum number of k consecutive bit flips. One was the greedy approach, second one used a queue, the third one removed the queue and optimized it even further. In this video, we'll be solving using the approaches 2 and 3. So I'll start with approach 2, then show you how to turn it into approach 3 without too many modifications. So let's begin. We'll implement the queue in JavaScript using an array. You can use any other data structure or language that you prefer. I'm going to stick to this implementation for simplicity. And of course, we will initialize our answer variable. Let's call it flip count. Now the algorithm said that we have to iterate over every element. So let's do that. For every element, we have to check whether the index at the beginning of the queue has it been flipped and has it influenced our current element, right? Basically what it says over here, check for valid flips for the current element. So in the second approach, we did it with using this condition. So while our current index is beyond the range of influence of the first index element at the first index of this queue, which is basically q0. Its range of influence is plus k minus 1, right? We already discussed this in the previous video. So if you haven't seen it, I highly recommend it, or this implementation may not be very clear. Now, if that is the case, we use the inbuilt shift function in JavaScript to remove the first element from the array. After that, we check whether the current element needs to be flipped or not. So the current element is found at the ith index. Now we have to check, is current element flipped? How did we check it? We took the length of the queue and we performed a modulus operation on it in such a manner. That tells us whether the current element is flipped. So if this value is 0, that means the element is still at its original value. But if it is 1, then the element has been flipped. Alright, that is what this implies. Now, how do we basically check this condition? I told you, right, we have two cases. Either we have 0 as our original value or 1 as our original value. So if current element is 0 and this current element has not been flipped. Let me just add some brackets for simplicity. So if this current element is 0 and if it has not been flipped, then we should be flipping it. When else should we be flipping our current element? We should be flipping it when the current element happens to be 1 and if this current element has been flipped, because 1 has been flipped, which means it is now 0, which means we have to flip it back to 1, right? So if it has been flipped, 1 means it has been flipped, right? Which means we have to flip this again. How do we process the flipping portion? Now, of course, scratch it out while discussing the third approach, but what this basically means that we have to add the current index to the queue. So that is very simple. We push it to our queue. And while we do that, we also increment the flip count. Now, this condition can be written more simply. Okay, don't get me wrong. This can be written much more simply. I'll leave that for you as homework. It can be written in a very short expression, but for simplicity, this is what I want to write right now. And we simply add the flip count over here, and we will be returning this as such. All right, let's run and see where we are right now. All right, small error, probably missed some bracket or something. But before checking the brackets, I think we're missing another condition. So let's not run too quickly. The condition is this one. Can we even flip the bit? Can we even flip our current element? Is the window valid for us to do so? So if I plus k, if it is greater than nums dot length, basically if our window happens to be beyond the array, we return -1. Alright. Now let's see where we went wrong with our brackets. I think this one is an extra bracket. Alright, the basic cases have been accepted. Let's try to submit this. Okay, this has been accepted. Now let's try to see how we can build up on this solution and move on to approach 3. So approach 3 said that instead of using a queue, which we'll comment out, we can use a variable. We will call this valid flip count. Alright. Now this flip count is our primary source of tracking of the number of flips that have been done on the current element, right? So we do that by replacing the queue over here. We simply say that whenever we perform a bit flip, valid flip count increments by 1, and of course the current element becomes 2, right? That was basically what we discussed in the previous video. And let's move on line by line. So this condition will of course change. So if not while, if nums I minus k is equal to 2, which basically means that we have encountered a flip operation that is outside our window, we will decrement this valid flip count by 1, because that, like I said, it's outside our window. We don't really need it anymore. But this may be causing some problems in the case where I is less than k, right? If I is 2, k is 3. I minus k will become -1. That is an issue for us. That is not valid, right? So I should be greater than or equal to k. And of course, all of this should match. That is when we decrement the value. And this flip count will now determine whether the current element has been flipped or not instead of the length of the queue. The rest of it remains pretty much the same. Let's try to run this. It's been accepted. Let's submit this. There you go. It's even faster than the one we had previously. And that's basically how we solve the question minimum number of k consecutive bit flips. And that's it for now. Thank you for watching. Follow for more.